Hi, today I'm going to show you how to make some cool designs using the Proximity POP. In particular, I'm going to be showing you how to check between the distance from a single point and any other given points in 3D space. We're going to be doing that using the Proximity POP's second input, as well as how to utilize that distance from each line and how to style it using copy and the line material. So to start, this is the actual whole network that you need. I'm going to delete it, and I'm going to start from scratch. I'm going to start with a point. This is a point on 0, 0, 0 in x, y, and z. So if I go to points, I can see it's 0, 0, 0 on x, y, and z. And if I have viewer active on, I can look at my attribute dots. So cool, I just have one point that I want to push around in 3D space. And I'm going to push it around with the noise pop, which will transform the distance based on a little bit of randomness. I also want to animate this, so I'm going to go to transform, and I'm going to multiply by abs_time.seconds. Cool. This is a bit fast, but this is the sort of random movement that we want. Semi-random. We get to ease and smooth between it. So I'm going to multiply this by a smaller value, so it's a little bit less fast. Make the period a little bit larger, so it's a bit smoother. And I'm actually going to limit this as well, because I don't want it to go beyond a certain bounding box. So I'm going to go to limit, and I'm going to make sure both limit type maximum and limit type minimum are on clamp, which means that they stay within -1 and 1, so it can keep giving infinite values or infinite random values, but it will not exceed these bounds. And what I'm going to do now is I'm going to create a field for my proximity pop to measure the distance between this moving point and a given number of points. So for example, I can make a bunch of points just to show you how proximity usually works. If I take a bunch of points and I put them into a proximity, it will look, I'll make this a little bit less, it will look within a given band of distances between 0.1 and 0, distance away from every single neighbor. So every single one of these is searching for the nearest neighbor or the nearest point within a distance. And once a point has multiple neighbors, we're going to go to a maximum of 3. So for this point, these were the 2 closest points. So when we do that here and we move these points around, we can see all of these are changing because the distances to each other are all changing. But if I wanted to look up the specific distance from one point in here to any other point, I would use the second input. So I could have my field in the second input and my point from earlier on 0, 0, 0. And I would see, if I zoomed really closely, that we are producing a line from 0 to the nearest point. It just so happens that our points are pretty far away here. So if in my proximity I increase this distance, this maximum distance, I can see that more points are being drawn further away because I'm looking at a broader band of nearest neighbors. Great, so we're going to do the same exact thing with a slightly different set of points with our pushed around point. So I'm going to connect my limit to this, and instead of point gen, I'm going to have a grid that I'm going to make slices on in all 3 dimensions. So what I mean by that is, if I turn viewer active on and I press W, I get to see a wireframe of this grid. And I want rows, columns, and slices, our X, Y, and Z, places that we put points, to all be the same. I want them to be at 5, 5, and 5. So now we're producing multiple grids in different dimensions, and right now we're only connecting them along X and Y. But we don't actually need to connect them at all because what we're actually after is the points that those intersections lie at. Great. So now I can have this as the source for my proximity, and it will check the distance between this one point and any of the other points in my grid. To make that a bit bigger, okay, cool. Now what I can do in proximity is I can change how many maximum points there are. And I can also, actually, for proximity, I don't want to be looking at all these blue points. I'm only concerned with this line that I'm producing, or this series of lines. So I can turn on remove unused points so that I'm only getting the outputted line. And furthermore, I do want to convert this to a line strip so that I can do certain line strip transformations to it. So I'm going to do a convert node and make sure that it is set to triangles, quads, and line to line strips. So that will change this, which was of type line, to line strip. This is some POPs specific terminology and not super useful outside of POPs. And what I'm going to do now is I'm going to line divide, which I couldn't have done before. Not line break. I'm going to line divide, and this is going to allow me to split each of these lines into more subdivisions. So if I just look at the points that exist on here, I have my starting point and I have my endpoints, which are what proximity has determined, and the lines connecting them. I can divide these further with line divide and visualize that. And I can see it's taking each of those lines and it's dividing it to have four more points in there, or three additional points, 4 segments. And the higher in divisions I go, the more fidelity I have for things like rendering later when I actually apply a pattern along this line. So what I want to do is I want to have a sort of pattern go along this line according to its distance. So in order to do that, I do need to grab the initial value of the position of this point. To do that, I'm going to go to chops, and I'm going to make a pop2, and that should be populated with x, y, and z. Oops, cool. That should be populated with p0, p1, and p2, which are constantly changing from our noise. What I'm able to do now is I'm able to set a field after this. And field essentially tells me any points relationship to a piece of geometry in space. So what I mean by that, if I go back to my point generator example, is for this point generator, I can determine the color of its particles, the color of its points, based off the relationship to a hypothetical box in that space. So I've set the field's type to box, which is of size 111, and I'm going to make sure the output is set to something that I can see, the color of this geometry. So now this is essentially a signed distance field of this box where we are thresholding and saying, if any of these points fall within this box, their color is going to be that. So we can now attach this to like an external attribute, one that doesn't exist, and write it to W. So whenever I need to use W to represent anything, like size of a particle or how it should look color-wise or the thickness of it, I can refer to that for all of my points. All of these points have their point positions, their normals, and this new W parameter that I've made. So in order to do that, I'm going to make sure that that box or that sphere that we're actually checking, that we're actually creating a new attribute for, is tracked to that point that's moving. In order to do that, I'm going to go to field transform, and I'm just going to chop reference on the translate parameters for x, y, and z. And now, if I go to field, I can make my sphere a bit smaller and ensure that my output is color as well. And I should be able to see, if I make my radius a bit smaller, I can see that my line has part of it in darkness and part of it that's inside of the sphere. So I'm going to make this a bit more fuzzy and actually linearly interpolate between the edges of this new field that we've created. And I think around 0.5 to 0.7 is right. And maybe bringing down the align a little bit. This is more up to preference. There's more absolute ways to check the distance of this line to this point, but I actually like to find control of field because if I want to change the underlying shape to something like a box, to something like a torus, I can, and still have it affect all of the lines equally. So what I'm going to do here is, okay, now I have something going from 0 to 1, 0 on the edges, 1 towards the center. How do I visualize this more clearly? I'm going to render it with a geometry, a camera, a render, and a line material. I'm going to make sure to drop that line onto the geo, and I should be able to start seeing something in the background. And right now, I can see a line where the color gets lighter as you get towards the edges. Great. So instead of color, I actually want this output field to not have any visual representation. So this is us with a constant thickness. And I'm able later in line to say, hey, I want you to look at this last node you made and look at the W parameter and attach that to our new width. It's not so obvious now, but if I go to the field and I turn that 2 range up to something like 10, I can see a clear fall off where as you get further away from the point, the thickness drops off. And I think there's more interesting ways to display this than just a simple linear interpolation. So why don't we try using a lookup curve to determine how this should look now? So all I have to do to create a lookup curve is create a lookup attribute pop. Pop my first input in. This is going to be what we're affecting. And our second input is going to be a curve whose values we're going to look up for our new thickness values. So I'm going to create a pattern, and I want to be sure to put this pattern inside of a math so that I can rearrange some of its values. In particular, I don't want this line to go into negative thickness, but this lookup curve, I'm going by the height of the curve. The height of the curve clearly goes up to 1 if this is 0, but actually goes down to -1. So we might get some weird looking things if we go into negatives. And I want to make sure that in my math, I say, take all things from range -1 to 1 and remap them to 0 to 1. And I don't want this to be x, y, and z. I just want to use the y parameter, which is p parentheses 1. So I'm only remapping this curve on its height. If I put this in as a lookup attribute, and I say inside of the lookup attribute in this order, I want to affect the width of my piece of geometry based on the position, particularly the height, to output a new width. If I put this into the geo, I should get something that looks like this. Slight correction, Feild should look a little bit more like this, with a smaller radius and a larger transition range. This just makes the fall off a little bit different, and it captures more values in that gray space that aren't strictly 0 or 1. That's why it was looking a little weird earlier. And with pattern, the only thing I did is I made sure to map my height to something a little bit larger, and making sure to remap that to something or vertically translate it. You can get the same result from this mapping matrix as you can by taking it and transforming it vertically by 3. So this is the same result, just different ways to get there for my lookup curve. And so now I have a lookup curve where my width is changing based off a sine wave. And I can actually update that sine wave further by animating it with phase. So cool, now my sine wave is going inwards towards my center. I can change the speed of that with more expressions. I can change how frequent that is happening. So if I want a higher frequency, I can show that here. I think it might look a little bit better with more arms. So I'm going to go back to proximity and change my max number of points. And great, we're getting something kind of like we saw before. If I go to render and I turn my background color to 1, I can put this up on a black background. And this actual input piece of lookup is really important and can help us do a lot just in this space by changing the curve type. So we can make it be a ramp, which is this sort of triangle structure, which might even look a little bit better if I'm transforming in the opposite direction or animating in the opposite direction. So now they're all going out, and I can imagine that as well instead. Cool, so I'll use my transform instead, and I'll bring that down a little. Oops. So that they're kind of disappearing down to nothing. So you might get a more starfish-like creature here. If I was to go back to using my old mapping and changing my pattern to something like square, I would see total disappearances because those thicknesses are dropping back down to 0 instantly. And this is where my line divide actually comes in. So if your line looks a little bit glitchy, make sure to have a higher amount of segments or divisions. If I go lower, it can be a little bit more unpredictable, but it's less expensive to compute than having all of those divisions. So this might be a cool way to generate something stylistic, but if we want them more traditionally dotted, we can do that. Oh yeah, and I said I would show you how to do this with copy as well. We can essentially use our new lookup attribute as a sizing parameter for a piece of geometry as well, instead of strictly using these two-dimensional rendering. So I'm going to get rid of line, and I'm going to put in Fong. I'm going to put Fong down, and make sure I have a light. And right now we're not going to see much, because we're just lighting this single line, which has a thickness of almost nothing. And Fong allows us to see shadow, and allows us to see like how light plays on a surface. So what I'm going to do is I'm going to make use of the sphere pop. I'm going to bring its frequency a little bit down to something like 2 or 3, and I can just use the copy pop, which is actually a little bit more efficient for pop parameters than doing normal instancing. And I want to make sure that sphere is on top, and my base piece of geometry is on bottom, and I can see that we get just a handful of spheres. What I'm going to do is I'm going to bring that radius a bit lower. So great, we have a great many spheres that are all right next to each other. And I make the E even smaller so that I can see the separation between them. Great, we have many, many spheres that are right along each other, and we're going to change their scale based off of a attribute. That attribute being under template, point scale, which I can simply just say, look at W. And now this is where the size of my initial sphere comes into play, because now we are offsetting from that initial size. And the lower I go, the more true to our original line implementation we had. I can now render with this. And we can see our worms flying off. Great, and let's go back to seeing what that looks like with a sign instead of the square. Great, so we get this sort of blobby effect. And as usual, like once we have these divided lines, we get a lot more fun things that happen once we introduce noise. So in the insert operator, I'm going to add a noise, and I'm going to see all of these sort of wiggly tendril-like things because all of a sudden these straight lines have to conform to underlying randomness or noise, pushing them around. So yeah, I hope this gives you a bunch of ideas. This also works directly. You don't have to use a single point in this parameter slot. If I bring down my scale a bit, maybe bring up my frequency, maybe something like 10, 10, 10. We might have something of the same frequency, but a bit smaller. And now I can just make any number of points. I could put a whole line in there with a whole series of points along them, each showing the distance from the field of points to the singular one. Now we aren't going to get the same stylings for the width off bat because currently our field is only locked to our first one. It's only locked to our first point, 0, 0, 0, that's being pushed around. But you can use the distance from proximity as well to show individually how each of these are relating to their point of reference. So yeah, I can create as many points as I want, and I'm sure you can create all sort of snaky, tendril-like creatures from this. Yeah, have fun.